So today we're going to do a little bit of cumulative review, just preparing for our cumulative exam 3 that's coming up later this week. It's just going to be a little taste of every single thing that we've covered so far in this course. It shouldn't be too long, but I want today to be a you try and then I go over kind of day. So in other words, when I pose a question, I want you to try it on a piece of loose leaf, take a couple minutes on that. Honestly, it might take a little while. And then once you've solved it, or if you're completely stuck, unpause the video and see how I solve it. Anyway, let's get going. So like I was kind of saying, oh, if it's even changing here, there we go. Like I was kind of saying, we're focusing on just practicing many of the areas we need to know for our cumulative exam. Remember that in Math 9 so far, we've covered quite a bit. Like we're almost at the end of this course already. There's only one topic we haven't covered, but the concepts that we have covered, however, are rational numbers. That was fractions. So we needed to know fraction operations. We needed to know how to compare fractions, etc. Powers and exponents, that included simplifying power statements. So in other words, using your exponent laws to combine things. Or even just evaluating powers and exponent statements. That often required you to understand BEDMAS. Exponents actually show up pretty early in BEDMAS. Then we had to look at polynomials. With polynomials, we simplified them. That just meant you collect your like terms. We also talked about adding, subtracting, multiplying, and dividing polynomials. We looked at linear equations and inequalities. An equation had an equal sign, of course, and an inequality just had like a less than or greater than symbol, those sort of things. Bottom line with that was we were just solving for x. We were getting x all by itself. It really required quite a bit of the combining like term stuff that we used in polynomials. We also had to know a bit about their graphs. I don't think we're really going to get into that today so much. That was always in the form y equals mx plus b, where b is your y-intercept. Or in other words, on a graph, it's where you're crossing like your y-axis, right? So if b was plus 7, you're way up here at 7. If b was like -4, you're down at -4. Hopefully you get the idea. M, however, that was a little bit more complicated. That was your slope. We'll get into that another time. I'm just, again, explaining everything that we've done so far. Symmetry and surface area, a lot of that was pretty self-explanatory. Surface area was challenging because it's usually quite time-consuming. I know in the Cumulative Review 3 booklet, there's a surface area question. I think it's with a house or a barn or something like that. It's quite long, but you know, it is what it is. Just break it down one piece at a time. And then everybody's favorite thing in the world, circle geometry. That's actually going to be the bulk of our cumulative exam 3. It is the most recent thing we've covered, of course. We'll do a couple questions on that today. Anyway, I'm going to stop rambling. That was already like 2 minutes of me just explaining things. Here we go. First question. Pretty sure I pulled this out of a PAT somewhere, like one of the ones that's published online. Which of the polygons above is proportional, that's a key word there, proportional to the shaded rectangle? I want you to pause the video here, see if you can figure this one out, and I'll go over it in just a second. All right, so hopefully you were able to see this one. The word proportional, like I mentioned, is pretty key here. Proportional just means that basically all of the sides have been multiplied by some number to turn it into something else. This is related to the idea of similar figures, where a similar figure is just something that had a scale factor from one to another. If you look at the shaded rectangle, it's 3 by 1. So if something has a comparable ratio, in other words, one side is 3 times longer than the other side, we can say it's proportional. If you look at this rectangle number 1 here, notice it's 1 by 6. That's not proportional because it's like this side is 6 times longer than this side, so it's not 1, that's for sure. 2, it's pretty clear that this isn't proportional as well because it's just a 1 by 1, whereas we need one side to be 3 times the other one, so that's not going to work. 4 is 3 by 2. Well, you know, this 3 side is not, you know, 3 times longer than 2, so unfortunately this one doesn't work. So that kind of narrows it down to this one, number 3 here. It's 2 by 6. Well, this 6 side is 3 times longer than the 2 side, right? So that kind of tells us it is proportional. Another way of doing proportionality is just to kind of say, hey, does it have the same general shape to it? Like you can kind of visually inspect it. And number 3 here definitely kind of has the same shape as this, obviously just turned around on the other side. Long story short, though, the answer here is C. It is 3, that is the one that is proportional. All right, circle geometry question. These ones are often a little tricky. The letter O is the center of the circle. The diagram shown above has not been drawn to scale, so I don't think you can put a protractor up against your screen here. If the sum of angle AOB and angle ACB is 75 degrees, then angle ACB equals what? Pause the video here, see if you can figure this one out. All right, so this one is pretty tricky. The fact that it says the sum of AOB and ACB is 75 degrees, That means obviously both of these have to be added together to equal 75 degrees. So how about I just for simplicity's sake, I'll call this one X and this one Y. And we're looking for Y here because ACB is what it's looking for. So we know X plus Y is 75 degrees. Now it would help, of course, if we actually really looked at our circle we got going on here. Angle AOB is this angle right here. So I'll call that X. And ACB, the one we're actually trying to find, ACB is this angle up here. So I'll call that Y just to make it a little simpler. Hopefully what you notice is that they have the same endpoints, or in other words, they're what we call subtended by the same arc. When you have two angles that are subtended by the same arc, if they're both inscribed angles like ACB, then they're going to actually have the same measure. But notice ACB is inscribed, it's made up of two chords, whereas AOB is made up of two radii and therefore is what we call a central angle. Well, there still is a relationship. Remember, central angles are twice, so 2 times the inscribed angle, as long as they are subtended by the same arc. In other words, as long as they have those same endpoints there. So this is actually going to help us out here. We know that this central angle X equals 2 times our Y value, so 2Y. More simply, perhaps it'd be better to say that we know that whatever ACB is, this angle Y, AOB is going to be double it. So you could kind of cheese this question. You could just look at the possible answers here and say, okay, ACB, the smaller angle here, if it was 30, then that means ACB would be double that. So ACB would have to be, or sorry, AOB would be double that. So it would have to be 60. Well, 30 plus 60 is 90, not 75. So we know it's not A. You could work your way down there. That's like, I call that cheesing the question because you're just kind of going through the options. But you can figure out this another way, actually. We can say that since X is the same thing as 2 times Y, we can just write that Y plus X, which is 2Y, equals 75. Well, Y plus 2Y is just 3Y, so 3Y is 75. Divide by 3 on both sides, and you're going to see Y is equal to 25. So right there, we can see that ACB, which is our Y, must be 25 degrees. Again, if you wanted to, I could have just literally gone one step further and just cheesed the question. I could have said, okay, if the smaller angle is 25 degrees and the other one is twice as big, then 2 times 25 is 50. So 25 plus 50 would be 75, and we'd be done right there. But, you know, there's always another way around. So whatever floats your boat on this one, go for it. All right, here's an evaluation question. Evaluate, just in case you've forgotten, means actually solve for the answer. I know some of you are pretty hasty just to type this in your calculator and say, okay, boom, got it, I'm done. I kind of advise that you actually follow BEDMAS on this one. So that's all I'm going to tell you before I give you a chance to do this one. Follow BEDMAS, try doing it one step at a time. Give you a couple minutes here, just pause the video, and I'll go over it in a second. All right, so I'm going to go over this one now. I'm going to follow BEDMAS. I'm not even going to touch my calculator, not to flex or anything here. Well, actually, I might have to actually touch my calculator in a couple of these, but just for the purpose of getting started here, I'm not going to touch my calculator initially, at least here. Okay, so BEDMAS, that's the order we have to do things when we are evaluating. So BEDMAS, of course, stands for brackets, exponents, division, multiplication. Remember, those are one step there, and addition and subtraction is also one step. You always do those from left to right when you get to each of those steps. So really, BEDMAS only has 4 pieces to it: B, E, and then DM, and then AS, right? So start with brackets. We actually do have a couple sets of brackets here. This -5 over here, nothing's going on, so we don't have to worry about that one. This one, however, we got 3 to the power of 2. You can, if you wish, want to evaluate that. 3 to the power of 2 is just 9. It's just 3 times 3. Or if you want, you could actually use the exponent on the outside here and use your exponent laws to make this 3 to the power of 6. It really doesn't make a difference, I'll be honest. So I'm just going to follow pure BEDMAS here. I don't really care about my exponent laws right now. So if I use BEDMAS, I'm going to say that this is 9 to the power of 3 minus 4 to the power of 4 plus 4 to the power of 2 times -5 to the power of 2. Now, the next step in BEDMAS, because I'm done my brackets now, do your exponents. 9 to the power of 3, when I was saying a second ago, I might have to touch my calculator. That's kind of the one I was looking at here. 9 to the power of 3, if you throw it in your calculator, you're going to see that's 729. Sure, you could figure that out without a calculator, but it just would take a couple seconds there, but whatever. Minus 4 to the power of 4, just so I'm not wrong here, I'm going to test that one on my calculator too. 4 to the power of 4 is 256. Plus 4 to the power of 2, I know that one, that's 16. And then times -5 to the power of 2. Notice -5 is in brackets here. That actually helps us out. This means we have -5 times -5. Well, -5 times -5 is positive 25. So that's what we're dealing with right there. Much better. Okay, so our exponents are all done. We've got this statement now. Really, I should put equal signs after or right before all of these. That's kind of the proper thing to do. I apologize. Next up, division multiplication. We only have one of those here. We have 16 times 25. Well, if you go 16 times 25, that actually gives you a very nice number, 400. So I'm going to throw that in here now. 729 minus 256 plus 400. And then we're almost done here. We're done our division multiplication. Now we just have to do addition and subtraction. Don't get carried away with the fact that it's spelled out as BEDMAS. You don't do addition before subtraction. They're both the same step. You do them from left to right. I've seen people do it in the past where they go, oh, A is next. I got to do addition. So then they add these two things. Don't do that. Addition and subtraction are the same step. I know BEDMAS is kind of weird that way, but it's just how it works. So long story short, we just do this from left to right. I'll break it down. We'll go 729 minus 256, and that's 473. So 473, and then we have that plus 400 still, right? This is still lined up. 473 plus 400, that one's not too bad. That's going to be 873, and that is our final answer. So we put a box around it just to make sure that we've said we're done. Okay, hopefully that was okay. BEDMAS is the order you follow things in. Don't go in guns blazing with your calculator and just say, boom, I'm going to throw this whole thing in and hope for the best. It can work, but you're also prone to making some mistakes, because unless you type in your calculator exactly how it needs to be, your calculator might, be unsure what the instructions are on this. You might be missing some context there. Anyway, just a good piece of advice to keep in mind. All right, next one. Which pair of expressions below are equivalent for all values of x? This is an interesting one. I want you to pause the video here, look at all of these possible answers, and I'll go over it in just a second. Okay, so this is kind of a polynomial question, I guess. So what's interesting here is you have to understand that as long as you take into account what sign is on each of your terms, remember terms are the things separated by addition or subtraction signs, you can actually rearrange your polynomial pretty much however you like. Now, generally speaking, we like arranging a polynomial in order of degree. So looking through all of these just before I even do the question, I like this one, how it's ordered right here, the negative 4x squared plus 3x minus 2. That's how we usually organize things. It goes from highest degree to lowest degree, but that doesn't matter here. That does not matter. So all we're going to do is we're going to look at each one of these. I want you to look at the sign of each of the terms. So I'm going to start with the very first one here on A. We've got negative 3x. Well, if we compare that to the one it's supposedly equal to, notice it says plus 3x. That's not the same thing, right? Negative 3x and positive 3x, those are not the same thing. So I can tell you right now, A is not the answer. If we look at B, we have negative 3x and negative 3x. So far, so good. Then we have plus 4x squared, plus 4x squared. Also, so far, so good. And then we have plus 2 and a positive 2. It's looking like B is going to be our answer here, but I want to just check the other ones just to be sure. We got positive 2, negative 2. Okay, that one is not going to work. That was quick. And then on D, we have positive 2, positive 2. Okay, negative 4x squared, positive 4x squared. Nope, that's not going to work. So the answer on this one is B. Don't always jump to an answer too quick. Notice how I continued looking through them just to be sure. I was quite confident that B was the answer. These are equivalent. They've just been rearranged just so they're in a different order for whatever reason. But it's a good idea to check through the other answers as well. Not to say you got to second guess yourself, but it's important to look at the whole thing. All right, next one, another circle geometry question. This is not a PAT style one. This is one I just put together. Suppose DCA, that's an angle. I should put an angle sign there. Angle DCA is 150 degrees. Find the measure of CAB. Pause the video here, give this one a shot. All right, so time to go over this one. DCA, first of all, I always love labeling this on my circle. DCA is this angle up here. We're going to say that's 150 degrees. Kind of a weird rule. We don't use this too often, but remember when you have a straight line and there's an angle that cuts that straight line into two pieces, the other angle, so this one I'm doing with kind of a dotted, arc right here, the other angle is going to make it add up to 180 degrees because a straight line is a straight angle and therefore 180 degrees. So this angle up here in the corner, BCA, I guess we can call it, that would be 30 degrees because that's what you would add to 150 to make it 180. So really, I just went 180 minus 150, which equals 30 degrees. That's not the measure of CAB, though. CAB is this guy down here. We'll call it X. Good news is we're almost done. Notice we have what we call a perpendicular bisector right here. It's a line that cuts a chord right into two pieces. We know it's a perpendicular bisector because it passes through the center of the circle. We can assume within good reason here, I really should have stated in the question, but we can assume with good reason that C is the center of the circle here. So we know it's a perpendicular bisector, meaning these two pieces are the same length. More importantly, in this context, we know there's a 90-degree angle that forms at CBA. We can use that 90-degree angle to help us find x, because just like with a straight angle, inside of a triangle, all of the angles have to add up to 180 degrees. So we're going to go 180 minus 90 to take away this 90-degree angle here, and we'll also minus 30 degrees from that. If you subtract all those together, you're going to find that our answer is going to be 60 degrees. So 60 degrees equals angle CAB. There we go. That one wasn't actually too long. That only a couple steps, but hopefully you're able to get it. Again, if you're still stuck on a lot of these things, make sure you're reaching out and asking for extra help. Anyway, here's another PAT question. I actually quite like this one. This is kind of a creative context. The two diagrams shown above that both represent an inequality of this, I'm purposely not saying what that is, I want you guys to interpret that, are numbered what? So two of these represent this inequality. Pause the video here, see if you can give this a try. All right, so I'm going to go over this one now. What this inequality here represents, the reason I didn't say it out loud is I didn't want to spoil it. This represents x is greater than 3, right? Think of this little greater than sign as being a mouth. It wants to eat the x because the x is the bigger number. So x is greater than 3 is what we're dealing with here. Just looking at these two scale diagrams, like we've never actually dealt with this in class. This is why I say it's kind of a cool way of thinking about it. Notice in diagram 1 right here, the x, which they represented as like a little pyramid thing, is weighing more than 3. So this would represent that x must be greater than 3. It has more mass than 3. So I know right now that 1 is going to represent like this inequality. So I can right off the bat knock out C and D because they don't contain 1 as a possible answer. So that just narrows it down to either 3 or 4. Fortunately, I actually feel more comfortable with these little graph things than I do with a scale, because when we say x is greater than 3, what that means x could be is x could be 4, x could be 5, it could be 6, etc. It could just be any number greater than 3. Notice on these little number line graphs, on 3 here, they've shaded the numbers bigger than 3. They've shaded 4, they've shaded 5. They put an open circle right here because we're not going to include 3. X is strictly greater than 3, not equal to 3, but it's, shaded in the ones that are above it. As for the other one, they've shaded all the numbers below it. Well, obviously, if x is greater than 3, we want the numbers bigger than 3. So this must therefore be the answer. So the answer to this question must be A, 1 and 3. All right, that's it. Hopefully that wasn't too much of a lesson here today. Again, there was nothing super new or anything. It was just kind of just a way of warming up and getting our practice ready. What I want you to be doing, though, for the rest of your block, however much time you have left here, Cumulative Review 3 booklet. I posted the answer key on Google Classroom. It's in our online week 1 post, so it should be there for you to find. If you have any questions, though, make sure you are reaching out and asking for some extra help.